Welcome to China Manufacturing Decoded from Sofeast, the podcast where we take you through some of the major topics facing importers and manufacturers in China today. Hi listener, welcome to episode 44 of the podcast. Adrian from Sofeast here, joined by our CEO Renaud and Renaud has many years of experience in Asia with quality, and so who better to speak with about today's topic, which is design for quality. If you're launching a new product onto the market soon, you'll want to make sure that it is the best possible quality. So by designing quality into it at a very early stage, you're going to save yourself time, money, improve its compliance, and of course its safety, amongst other things. So let's explore DFQ reviews and how you can use them to improve your product quality. Hi Renaud, thanks for being with me today.
Hey Adrian, yeah, great. Let's kick off this new topic.
Yeah, a topic that I think is going to be interesting, especially given your long experience in quality. We're talking about design for quality, so that's DFQ. So today I want you to go into some detail about what this concept is when we're looking at the designing of new products and when we're bringing new products to market. So I suppose a good starting point is to just talk about the design stage of your new product introduction. Why is this stage so important?
So, well, every new product starts, by like a rough concept, and then it gets refined, it gets closer to the final product. People say, okay, this is what it's going to look like exactly, including the material, texture, and finishing, and so on. Here's the function it's going to provide, and so on and so forth. And well, there are certain products where it's a very well-known path, and you don't really have to worry about like unknown risks. But for a lot of electronic products, electrical home appliances, mechanical products, and so on that are new, it's really important to think, to basically pause and think at some point. So before you go into all the small details of the product design and you freeze the product design, and you confirm the product design through prototypes, which takes time, can be quite costly. Before you go further into, doing a lot of testing, making the jump into paying for tooling, and like making the jump into ordering a large number of components and going into mass production, it's better to pause and think and wonder what are the risks, right? And this is not just at one point in the process. This should come, ideally at several stages in the process of new product introduction. It could come at the time when the rough concept of the product design starts to appear and be relatively clear, and then people at that stage can think, well, how is this going to be made? What material is this? Like, for example, the enclosure. Oh, what is it going to be? Is it going to be plastic? Okay. So, and what are the requirements for usage and for selling and so on? What are all the requirements? Let's make sure we really translate that into clear specifications that will be useful for mass production, and really think of really what are the requirements, okay, for the product. So if it's going to be, for example, a plastic enclosure, okay, now how is it going to be assembled? What kind of temperature is it going to be subjected to? What specific requirements, like maybe it's got to be in water a little bit, or there might be some splashes and it has to keep all that water outside. Well, that's a very specific requirement. That's not uncommon, but it definitely impacts the type of welding, or how to close the enclosure, basically, right? These are just a few examples. So you need to, when people really try to think of the materials and the processes that will go into their product design. They need to think exactly how to specify the requirements and what could go wrong, what could have a negative impact on product quality, right? And when I say negative impact on product quality, it's not only manufacturing issues that are likely, like, I don't know, they want to have a very smooth surface that's anodized on a metal part that is cast. And well, especially with certain types of alloys and pressure and temperature settings and things like that, it's just not possible because it's too porous. We know that this, that kind of alloy, that kind of material, when it's die cast, tends to be porous. So you can't do certain things, you can't do certain kinds of finishing, or you're going to have a lot of quality issues, right? So this is what we call a manufacturing quality issue. There are also design-related quality issues, or as they used to call it in the old military standards, design deficiencies. Maybe it's more, it's nicer to say to a designer. So there might be actually a lot of deficiencies coming from the design, coming from the way the product was designed, that make it much more likely for the product to fail in the hands of users, or in the field, or wherever it's used, consumed, or installed, right? So let's say to get back to your question, there's a new product. The new product design, the concept becomes clear. People need to think of the materials and the processes, and then need to think, okay, given what we know about these materials and these processes, what could go wrong, right? What is likely to go wrong, and also how to specify it. Because you can just come to a manufacturer and say, hey, it's got to look good, it's got to be fast. No, these are maybe requirements coming out of the mouth of potential users, but these are not specifications.
Right.
You don't want to go with very fuzzy kind of specifications, because when the manufacturer actually says, well, we can't, that's the best we can do, then you cannot complain. Oh, I said my electrical skateboard has to be fast. Yeah, I think 25 kilometers an hour is fast. Are you kidding? It's got to go at least 40, right? But you didn't say it. So
right.
You need to specify these kind of things. And sometimes it means how to test it. How to test this. For example, okay, electrical skateboard. It's got to work, it's got to go uphill. Okay, what percentage of tilt, right? And for how long? And it's got to be able to go on like a rough road. Oh, okay. So that already is a little bit harder to replicate. So we got to think about that. These are just some examples. And then later in the new product introduction process, the product design, gets firmed up, and then you have, your prototypes to confirm it looks good, it functions good. It you subject the prototypes to the tests, and all the specifications that you set up. And all along, actually, it's good to have an eye on the kind of issues that I mentioned. And very often the formal reviews of the design for quality then come before investment in tooling, because really if there is relatively expensive tooling, once you've green lighted the investment in the tooling and you've wired the money, and it's kind of hard to go back and make changes. So it's really important to have some reviews and really think through it, get all the feedback possible. So that kind of feedback can come from the manufacturer. We provide a lot of feedback to our customers, but most manufacturers are not good at doing that. I mean, it's kind of weird to me because if there are especially manufacturing issues, that the product design makes relatively likely, well, who's going to suffer from it? Of course, the customer, if they get the bad parts, the bad product, but the manufacturer is going to suffer from it. I mean, imagine they have to rework, to scrap, to, I mean, it's extremely costly when there are manufacturing issues that are detected at the factory, right? So
Yeah.
the manufacturer can help, but in most cases they don't do a great job at that. So then, it's got to be an experienced engineer, and again with understanding and experience on the materials and the processes. Really, it comes down to that.
And you mentioned the tooling, for example, and by the time you've got the tooling invested in, you're pretty much ready to go into production, of course. That's a terrible time to be making wholesale changes to a product design.
Oh yeah. Oh, well, there is a truth that has been observed across manufacturing industries, but also in software development and others. When you have, okay, when you develop a new product, you have the rough design concept. If you already know at that point, okay, we can't do that, I don't know, again, the enclosure in plastic, because it's so common. If the walls don't have equal thickness, that's going to be an issue here. Or doing, what, or certain size, certain shapes just cannot be molded. It's just impossible. Or it makes the mold extremely complicated and more costly. So anyway, if you think of all these kinds of things, when you're just starting to draw some sketches, it's very fast and cheap to make a change. Oh yeah, no, I should not do that because, okay, let me change it this way. It's, it's negligible. The cost in time and money is negligible.
Hmm.
Now, if you go deeper and deeper and deeper into your 3D drawings, it might be 10 times more expensive to go back and make a change. Then you start to make prototypes, and then on your third prototype, you see that really you cannot get rid of that problem. Oh, then we go back a little bit to the drawing board and make a change to the material, for example, or to the kind of finishing or whatnot. And this is again probably about 10 times more expensive and longer than just making a change on 3D drawings. And then if you go all the way through production and you have 5,000 pieces that have a problem, this might cost again 10 times more. So this is this 10x sort of jump from one stage to the next. It might not be 1 to 10, right? But might be 1 to 20, and then 20 to 50, and then 50 to 150 or something like that. But really, it goes up exponentially. So the earlier you make the adjustments to the design to take into account the realities and the constraints of production, and of the materials, well, that's the better, the cheaper and the faster, definitely.
Yeah, okay. So that makes a lot of sense. And you mentioned undertaking certain reviews earlier to help in terms of doing that. And one of the reviews, of course, is what we're talking about, which is design for quality. So if we're going to be performing this sort of review quite early on in the new product development process, around the time that you are firming up your concept and you're quite far away from production at this point, what are the sort of principles in DFQ that we're going to be following?
Sure. There are a few principles that that we listed, and I'm going to go through them here.
Mm-hmm.
First, understand past issues and learn from past mistakes. So if you've been developing a certain kind of product and you go for your next version, just remember what went wrong in the previous versions, learn from it, and avoid the same mistakes. So this is really pretty obvious, right? It sounds pretty obvious. People don't always do it, except when it's very, very painful, of course. They cannot skip it or forget it, but this is the first one. I mean, pretty obvious. Second one is, as I said, identify issues or potential issues as early as possible. Don't wait for too long, and design the problems out of the product, sort of. So there's a famous quote from Edward Deming saying, "You can't inspect quality into a product, but I'm not sure exactly how he said it, but you can design quality in, right? So how to design quality into a product, well, by thinking in advance of what kind of problems there are and so on and so forth. And it's not design for quality is not only product design, it's also process design, right? I didn't really cover that, but when you pick the process, but also when you work on the right settings of the process and so on. Some processes are very mature, and there's no, I don't know, if you want to do some CNC milling to remove some materials on it, and the design is not very complicated. There's no real unknowns. Okay. However, if you go for, I don't know, silver powder coating on aluminum, or if you go for some processes that tend to have a low yield, meaning that they tend to come with a lot of defects. It's a different story, and you need to work on the process and maybe do some specific experiments and small runs, and again a small run, and again a small run, and so on, to really confirm the process before you go into production, right? So so this one was identify issues early, design them out. The next one is, whenever you can, if you can error proof, mistake proof the design, that's the best. And one example, for example, let's say you're thinking of assembly. How is the product going to be assembled? Or maybe drilled. Okay, that's a very typical example. If there's a drilling, maybe it's furniture. Okay, you're going to drill some holes in the product. Well, what is one of the most common failure modes, one of the most common sources of defects that happen in the manufacturing of furniture, is that the operator grabs the part, puts it into his fixture and drills, but he did not orient it correctly. Maybe he put it upside down or something like that. And then, of course, the hole is not well positioned.
Yeah.
But if the fixture actually allows that to happen, that's, maybe 98% of the time he will get it right, and 2% of the time he will get it wrong. I mean, it's manual labor. You count on someone to think and do that and avoid the mistake. There's going to be, if he does it 10,000 times, there's going to be some defects. So think of how to avoid it. So here it's really about the process, but change the fixture so that he can only put it in a certain way. And it can be very easy, just adding a pin to make it impossible to put the part on the other orientation, for example. Okay. The next principle is to simplify the design. I mean, this sounds dumb, but the simpler the design, the lower the risk of quality issues. And this might mean not going for as many functionalities, maybe if it's an electronic product, but some simple things. I mean, instead of having two pieces, try to have one piece. Then you actually get the fabrication of one piece, and after that you don't need to assemble them. So there's one less opportunity to make mistakes, right? The next one is tolerances. So not going to go into that in depth, but you want your design to be robust, and a robust design is a design that does not have any design deficiencies, and that will be relatively easy to manufacture at the right quality level. Okay, so one example of that is the tolerances. If your design really needs very tight tolerances, of course, there are more opportunities for issues than if it requires, loose sort of tolerances. If it's plus or minus 1 mm, it's much easier than plus or minus 0.01 mm, right? That's an example here. The parts, the next one is standardize as much as you can. Try to have as few custom parts as possible. So again, I'm thinking of hard goods here and the mechanical parts. Try to buy commercial off-the-shelf parts wherever possible, where it doesn't really impact the user that much, and so on. There are some interesting teardowns of super complex and highly engineered products. On YouTube is easy to find, and then they would open it and they would find, wow, oh, this is custom developed, and this is also custom developed, and this is also custom developed. Wow, it's amazing. So it's extremely tempting for designers and product engineers to really custom design, as many parts as possible. The problem is, well, you're just multiplying the opportunities for issues, right? However, if it's because every one of them is new, and every one of them might have some issues that were not thought of. However, when it's commercial off the shelf, it's much safer. It's been maybe made 10 million times or 10,000 times, but it's been made already at volume, and hopefully the issues have been found out and addressed, right?
From a supply chain risks perspective as well, the standard parts are going to be much safer.
Totally. So if you need custom parts, you might need again to invest in tooling. You're more at the mercy of one supplier. I mean, it's yes, definitely. And then one more general principle is try to have a multifunctional team. Okay, don't try to just ask the designer to think about that, or dump it on the lap of an engineer and say, hey, look at that, what do you think? The best reviews are done, maybe 3 or 4 people looking together at the same drawings and asking questions and pointing out to potential issues and so on, right? So try to involve more people, including, if possible, people from manufacturing. Again, manufacturers should have a lot of feedback, a lot of input on that, right? Because they know a lot of the limitations of their processes.
I suppose best case, you're going to be able to rely on your Chinese or Asian manufacturer to give you some or all of this sort of information. I'm just thinking, with anyone who's manufacturing a new product, and perhaps they need to cover a lot of new ground, and by necessity there's going to be a lot of checking done because there could be a lot of risks with the new product. But if, as you said earlier, a Chinese manufacturer, for example, may not be particularly great at identifying issues early in the process and reducing those quality risks, how do you actually go about getting that information? Who can you rely on?
Well, some engineering firms might be able to help, or companies like ours. So the problem with the big problem with the manufacturers is that they might say that they do design for manufacturing, design for quality types of reviews, but if they don't really do it, if they don't really spend the time to do it seriously, how will you know? That's the problem. Is that if they don't raise some issues, but you don't know about those issues, right? So how will you know that it was poorly done? That's a common concern here, and it's everywhere. I mean, it's also, for example, the guys who fabricate the tooling. They will say, oh yeah, we do a DFM review, blah blah blah. Just to make sure it's possible to make the parts like that. But they don't really spend much time, when studying the 3D drawings of the tooling to be made. What's the impact really on the process of casting, of extruding, of molding? What's really the impact? Maybe they're not going to be the one doing it, because very often the fabrication of tools is outsourced, so they don't really care. So if you ask them, say, yeah, we do it, we do a little review, and they might, but sometimes they do. Sometimes they give you a PowerPoint document with some screen captures and some comments and so on. That's great, but we haven't found so many doing that.
Yeah, I guess it depends on the manufacturer, because as you've mentioned in earlier podcast episodes, a lot of the manufacturers, it's not in their interest to hang about when it comes to the early stages of production. They want to get to production and get the components or the goods out and shipped, right?
Very true. They want to go to mass production, get paid, ship the products out, get to the next batch. It's it's a big machine, doesn't want to stop, needs to be fed permanently, and makes its money on production.
Okay, so to continue on the theme of quality, I think it's going to be helpful to talk about some of the common errors or mistakes that can produce poor quality products. And I guess these mistakes are what we're trying to weed out when we're actually doing a DFQ review.
Right. So the first one I already kind of commented on is the wrong tolerances on mechanical designs, on mechanical drawings, sorry. So if you stipulate a very tight tolerance, and sometimes the manufacturer doesn't really pay attention to it, and they say, okay, and then 80%, 90%, or 100% of the first batch is outside of tolerance, what will you do? You can't. You got to be quite careful, because again, the typical Chinese manufacturer or even Vietnamese manufacturer sometimes doesn't pay attention to these things. It's like, okay, I see the shape, I see, okay, we can do it, and they don't look at all the tolerances. So they might say, okay, get your money, get production going, and then they'll be surprised. Oh, you really want that kind of tolerance? Oh, that's really tight. We can't do it. Sorry. Oh, you really want to do it? Whoa, then the price has to double because we have so much scrap, right? So make sure you confirm that with them, because specifications that are too tight, standards that are too high are going to be a problem. And then we have the opposite, the converse of that, which is missing tolerances, or tolerances that are too loose, because people don't, the people on the design team maybe will say, well, we get the prototypes and everything is good, so they just need to do the same. Why should we decide on tolerances? Well, I mean, prototypes are not made with the same people and the same equipment, even in the same facility, as mass production. So you can't count on mass production to be the same. If you do assume it's the same, you don't understand the basics of manufacturing in Asia. So you absolutely need to have some tolerances, at least on the critical dimensions, right? And all of this is the same. So here I'm talking about dimensions and tolerances on drawings, but it's all the same with other dimensions of performance, right? You need to think, okay, if they don't do it right, how am I going to catch it, right?
Yeah.
Something else, when the design team is working and they get prototypes and they give feedback on prototypes, well, it's the feedback from the people who've been working on the design and who've been really working on it, hours and hours and days and months maybe. So it's no longer the same feedback as the typical target users. So it might be easy to use for these engineers, but not easy to use for final end users. That's an example. And really, we're talking about design for quality. I mean, quality, you want your customers to come back. Basically, that's quality, right? And if your end users, your consumers are not happy about it, can't use it for some reason, then you failed. Quality is not good, right? So you need to pay attention to that. Another one is the absence of accelerated testing or stress testing to confirm that the design, the product design doesn't come with serious weaknesses. So a product, I don't know, let me see, what kind of product could I take here? An office chair, okay? Let's say you're designing a new office chair. Well, what kind of accelerated testing could be done on an office chair just to make sure that the product, the way you designed it, is going to survive? And maybe you want it to survive at least 3 years with typical usage, of someone sitting on it, 5 days a week, standing up, getting down, standing up, getting down, and so on. And so if you replicate that, let's call it reliability testing. But if you really want to push the design, that's also something important. You might want to push, accelerate until failure, or maybe replicate something like 10 years, maybe only on 1, 2, 3 samples, maybe just a few prototypes, maybe just one prototype, to see when it breaks and why it breaks, right? Maybe it lasts for 5 years, and then one of the feet breaks. Well, now the number one weakness is the fit, and maybe you want to do something about it, right? Another one is about the process, the manufacturing process. If you need, well, for example, your design chair, the feet, the arms of the feet have to be cast, okay, and it's a specific design and specific mold, okay. Well, if you ask a die casting plant to make 10,000 of them, how many of them are going to be good the first time, right? If 10,000 of them, 100% are good, then the capability for that specific process is 100%. That's great. It's not really going to happen, right? If it's 98, 99%, might be pretty good already, right? So you need to think about that, and you need to you need to confirm first, through reviews, that the design for that process and that material and so on is not likely to come with low capability. If you have a doubt, you have to run some pilots, some pre-production pilot runs, and actually have someone on site to look at capability. I mean, when we do that, sometimes when we're worried, we have an engineer on site looking at what they're doing and really counting, because sometimes they do a pre-production pilot run. Maybe they make 100 pieces or parts or 50 parts, and then maybe 30 of them are good and the rest need to be reworked. Wow, that's pretty bad, right? That's 60% capability, first time capability. And then if they don't say it, well, later they will say, oh yeah, but we have a lot of rework to do and blah blah blah, and then the price of the part has to be up 40%. Actually, very very common in China, right? Or maybe their real capability is 90%, but then they tell you stories and they tell you that 30 or 40% have to be reworked. It's not true, but still. So if you're not sure, if you don't have the information, you don't know how to fight back. And then the last kind of example really is about compliance testing, typically safety testing to safety standards. So if you don't do the work of actually confirming that the product with that material made that way is compliant to the standards of the countries where it's going to be sold, hey, you know what's going to happen. Maybe your product is blocked by the customs. Maybe there is an issue, and then you're sued, and then you can be in deep trouble, basically.
Oh yeah, nightmare.
So compliance is part of quality. I mean, it's something you need to think of, and you need to you need to do the work and pay the testing fees, basically.
Yeah, very sensible step. You already mentioned that we are, of course, one of the sort of companies that can help with something like a DFQ review for different customers. Do you have any examples where we've actually used this sort of review and it's improved a customer's product before it went to production? Obviously, can't give any confidential information, but
well, yeah, a lot. I mean, just an example of batteries. So if the electrodes are not kept, far away enough, and if there's not sufficient packing, basically protection of the battery, to make sure that the electrodes don't come into contact, there might be a lot of issues. The battery, maybe it drops on the floor, maybe whatever happens, it might start a fire, or it might explode, right? Same thing as the Samsung, what is it, Note 7, right?
the legendary phone.
Yeah, right. And actually, this is kind of a typical kind of issue. So in their case, in the Samsung case, it was insufficient protection. So in some cases, it was dropped or whatever. There was a shock, and then the things that should never be in contact, could get in contact. That's a bit scary. But when people design their own battery packs, there's a lot of potential for problems. So yeah, insufficient protection and things are not tight enough. That's a typical case. But really, I mean, I think I've mentioned a number of examples of problems. I don't know. Maybe people come to us and they want the product to be IP66 or IP67 rated, which means it can be splashed with water or be underwater. Well, there's certain things that are definitely no that you cannot use to assemble the outside of the product, right? And you might have to go with ultrasonic welding and these types of processes, right? In other cases, it's, I don't know, you have a piece of plastic that will have to be force fit, and that means you can use certain kinds of plastics that are not brittle, but you absolutely have to avoid the kinds of plastic that are a bit too brittle. Or same thing with the magnets, for example. Magnets are very brittle, so if you have to force fit them somewhere, and they might just break.
Yeah.
I mean, there's a lot of issues like that.
But amazing, these sorts of issues that will come up once somebody who has that sort of technical expertise is looking at a situation that I can well imagine a lot of manufacturers might miss when they're thinking about designing products.
Yes, and very often they have to ask their own suppliers, because their own suppliers are the specialists of the the tooling and the materials, and some of the fabrication processes that are
Hmm.
not done by the company that will manufacture and export the products, right? Just do the assembly. Maybe they don't know a lot of these things. So sometimes just by forcing a dialogue with their sub-suppliers, it's possible to get a lot of this feedback too. But if you don't force it, again, the typical Chinese manufacturer will not provide a lot of feedback.
Right, okay. Good advice there. Great. Well, I'll add some notes to the show notes with some links to more information about DFQ and some of the things that we provide as well. So anybody listening who's interested, you can read more. And other than that, thanks for joining me. That's very, very helpful information about design for quality today.
Hey, great. Yeah, thanks, Adrian. It was a good one.
Great. Great. Cheers, Renaud. Thanks for joining us. If you've enjoyed today's podcast, don't forget to like and share, and you can subscribe on Apple Podcasts, Spotify, and all other places that you get your podcasts from. See you next time.